So pretty much that's all you're going to be using in terms of working out questions. So that's pretty much the baseline. There's this type questions as well, which is right, this one right here. Have a read of this.
pH. So weak base, strong acid, or is it?
Yeah. So the question that we did before, we talked about working out the pH for a weak acid, because we know without types of questions that carbonic acid is a weak acid, yeah?
No, it's a weak base, this one. Dissociation of a weak base, okay.
Yep, so this is just a type of question to work out the pH of a weak base.
What's KB? Why is it called KB?
So Ka is the constant for acids and Kb is the constant.
Ah, right, okay.
So similar, I'm just going to go through this quickly. Similar idea, because you might get this as a question. Similar idea is that acetic acid, you're going to do, again, because you remember, you do pH, to work out the pOH, you do 14 minus the pH, remember that?
Oh, yep.
So you're going to get 9.24, which is your pKb. So you do 10 to the power of your pKb. Can you see right here?
Yep. Oh, yeah.
Right here. So that's going to give you an answer. That's going to be your Kb value. Again, same situation, x squared over 0.01 minus x, same situation, same dissociation constant, if you want to call it the fancy word. So your products, your products over your reactants, right?
Yep.
Same situation, you ignore the x, and you're just going to take, as you told me, take over 0.01 over to the 5.75 times 10 to the negative 10.
Yep.
Square root it, get an answer for OH, and then negative log it. And then 14 minus.
Okay.
Make sense? So it's pretty much the exact same situation. The only two things that change if you get a question to do with acids or you get a question to do with base, which in this case is a base question. Firstly, when you get your pKb, you do 14 minus the pKb.
Okay.
Because remember up here, you didn't do anything about it. You just took the pKa value of 6.5 and you put it 10 to the power of, yeah? You did nothing to it. But in this situation, because remember we're doing base, have I lost the question? No, I haven't. You have to do 14 minus the pKa to get pKb.
Okay.
Can you see right here? So 14 minus pKa, which you get, can you see right here? So here, if that makes life easier. So the pKa was 4.6, but you want the pKb, so you do 14 minus the pKa to get pKb.
Yep.
And the other thing that changes is here, the pH, because you know how to work out the hydroxide value. Remember, 14 minus the pH to get pOH, yeah?
Yep.
Same thing. That's all. Still with me?
Yep. So, so you get your pH value minus find your pOH value, stick your pOH value minus 10 to the power. That gives you your pKb value, and then the rest is the same, is it?
Mm-hmm. So it's pretty much step one changes and the last step changes. That's the only difference. Where both of the first and the last steps is you're just going to do 14 minus the answer you get.
Okay.
Does that make sense?
Yeah.
Do you just want to write down, so it doesn't take a lot of time, just write that if you're working out an answer for a base, the only changes are the first and the last step, which is you're going to do 14 minus your pKa value to get your pKb.
So for your base, you have to find
your pKb.
Yeah, pKb.
And to work out the pKb, you do 14 minus the pKa.
pKb, which is 14 minus pKa.
Mm-hmm.
Ka. Okay.
Yep. And then your last step, remember, if you're working on hydroxide, you know this, is to work out the pOH, you do, to work out PC, to work out the
Yeah.
pH, you do 14 minus pOH.
Yeah.
Can you see right here? Yep. So, because when you did the negative log of this number, 2.4 times 10 to the negative 6, you got 5.6. That's your pOH. And to work out the pH, you do 14 minus that.
Okay.
Make sense?
Yep.
Cool. All right. That's pretty much your dissociation constant question. Now let's do a bit of buffers, yeah? For the last 10 minutes or so. And then I'll let you go
Okay.
because you seem tired today.
Yep.